In our previous section, we had already seen the calculation of returns for the three indices Nifty, Nikkei, and Dow Jones, and that was done after cleaning the database and putting the data for days when the data was not available by using the if error condition. Now we move ahead and calculate the rest of our data points around the returns of these indices and try and identify how do we calculate the returns of these indices, right? So for the first thing, we would look at what is the average daily return. Let's try and calculate that. So that's fairly straightforward. We can basically use the average function and we should be able to calculate the average daily returns. And we see that these numbers would be kind of positive for all three because indices have gone up in all the three cases, right? The risk factors or standard deviations, so daily standard deviation can also be found using this function called stdev, and you could select this data and that gives you the standard deviation data as well. I'll have to convert this to percentages, and that's the standard deviation data for them. So that's the risk that this particular index gives you on a day-to-day basis, and based on these standard deviations you could then go ahead and create the distribution profile based on what assumption you make there. So that's beyond the scope at this point of time for this discussion. We don't worry about that as we look at. Can we count number of positive days? Number of positive days. So we could count the number of positive days by using count if. So we use count if. This is the range and greater than 0 is what we are counting for. We'll have to put this greater than 0 into apostrophes. And that gives us 720 days where it was greater than 0. And the same for the other indices as well is what we have calculated. Total number of days, trading days, that's straight account function where, remember, trading days is what we are looking at, so that will be a single index and that will be one more than the the one more than the returns days because returns will be 1 day lesser. So that's the total number of trading days that we have calculated, and that's going to be 1428 for every one of these that we look at, right? So that's basically the calculation that we have done. Now, the next task is in terms of trying to find out the annualized returns, or in other words, what is the CAGR here? Right now, this becomes a little bit tricky for us is because for all practical purposes, the CAGR calculations that we had seen so far would use exact number of years. In this case, the number of years will be a decimal point. Sorry. So let's look at what is going to be the data point that comes out and how do we really go about calculating this set of years and calculating the CAGR based on that. So what we have here is, let's say you were investing for 2 years and the index went from 1000 to 2000 over this 2 year period. So 1000 into 1 plus the growth rate square is equals to 2000. So this would work out to 2000 by 1000 raised to the power 1 by 2 minus 1 is going to give me the growth number, right? Now this 2 here is the number of years, right? So we need to find out the number of years here. What is the number of years that we are talking about? right? And then we can find out the annual returns. Now, remember, when we have the total number of days, we can't really divide it by 365 because this will give us a number lesser, because the stock markets don't trade on certain days like Saturdays and Sundays, right? So we can't use this directly. We will have to find out the total number of days during the year as, so let's put as total number of trading days as this data, and then total number of days will be nothing but the last date minus the first date, and that's 2069. That's the total number of days that are there, right? Now can I convert this to years? This is possible to convert to years. So let's insert a couple of rows, then total years of data. I just divide this by 365, right? Now, what is the absolute total return? Total return that we have made. On Nifty, we invested at a value of 5232. We invested at a value of 5232, and that turned into a value of 7,600 odd, 7655. So the total return would be 7655 minus 5232 divided by 5232 for Nifty. That is the total return made over this period of 5.5 years or so. Correct? The return for Japan has been 67%. The return for Dow Jones will be 52%. That's the total return that we have seen. In other words, we have taken the value 5232. That's the value, right? 5232, and we are trying to calculate the CAGR now, let's say. So we are saying that 5232 growing at a certain rate 1 plus G for 5.67 years should give us 7655, right? So how do I solve for the growth? That's 7655 by 5232 raised to the power 1 by 1.5, 1 by 5.67 minus 1. Get the point? Let's do this again so that it's clearer for everyone. We look at 5232 into 1 plus whatever is the CAGR raised to the power 5.67 years. That's what we get here, is equal to 7655. This is the Nifty on day 1, and this is Nifty on final day, right? So we get these values. So 1 plus G 5.6 raised to the power 5.67 is 7655 by 5232, and that implies that 1 plus G is equals to 7655 by 5232 raised to the power 1 by 5.67, and then this 1 goes on the other side and this becomes minus 1, and we should get our answer. Correct? So let's try and solve this and get our answer. So I'll put a bracket and put the final value divided by the first value raised to the power 1 by, where is our number, 5.67 years, and I will freeze this because we'll drag this on the right hand side, and then we don't want this to change. And what we get here is over this 5-year period, the return on Nifty has been close to about 7%, and so on and so forth. You can calculate this. So that is how you would go about calculating the annualized returns. Remember, you need to find out the exact total number of days that are there, because Excel stores all this data in the format of all the dates in the format of numbers as well. At the back end, you can just subtract one date from another and get the number of days that are available. This translates into 5.67 years. Money invested in 5.67 years at 6.94% will give us say 7655 from 5232. So that's the CAGR or annualized return that we have calculated here, right? So that's the annualized calculated return that we get, and we get our solutions to the annualized average returns that we have gotten over this period. Now, one final thing that we should consider is how do we annualize the standard deviation. Just remember this as a concept. In finance, all calculations are calculated on are done on something known as variance. Variance is nothing but standard deviation square, right? And there are 250 odd trading days in the year. We can calculate how many trading days on average in the year, right? How many years were we looking at? 5.67, and we have 1428 as the number. So average trading days per year is nothing but 1428 divided by 5.67, and you see we get a number of close to 252, right? So we have 252 trading days during the year. So to annualize the variance, so first we take the standard deviation, square it, and then we multiply it with 250. That is the annualized variance. And then you can use this data and take the under root of this to get the annualized standard deviation, right? Taking the under root of this would mean standard deviation multiplied by square root of 250 itself, right? If I have, so the process is I first take the standard deviation, square it to get the variance, multiply it with 250 to get the annual variance, and then take the square root of this to get the annual standard deviation. If I open this up, this will be the standard deviation into the square root of 250 days, and that will be my annual standard deviation or annualized standard deviation, right? So let's calculate that very quickly. This is going to be 1.07 into square root of, and in fact I can link this 252 here so that number is there. We'll freeze the 252 bit and we can drag it on the right hand side, and we get the annualized standard deviation of Nifty as 17%, Nikkei as 21%, and Dow Jones as 14%. So that completes the entire second part that we had in terms of our discussion on how do we calculate all these returns, average returns, standard deviations, etc., statistical data calculation on these index returns that we have seen. The third part around charting is going to follow in the subsequent section.